All right, so for part B here, we're going to deal with resonance. And if we remember, resonance is just multiple ways to draw the same compound and still be accurate and correct. And what's going to be different with all these is the placement of usually a double bond. So let's take a look at SO3. Same setup. Figure out how many electrons we would want. There's one sulfur. Sulfur would love to have 8. There are 3 oxygens. Oxygen would love to have 8, so it's going to give us 32. Still one sulfur. Sulfur's in group 16, so it has 6 valence electrons. Well, so is oxygen, so that's going to give us 24. 32 minus 24 will give us 8. Divide that by 2 tells us that we need 4 bonds. So we're going to put our sulfur surrounded by 3 oxygens. 1, 2, 3 bonds. It says we need 4, so let's just arbitrarily choose one of these to be a double bond. So there's our electrons. That's going to make everything happy. And then suppose we had done this keeping the sulfurs and oxygens in the same place relative to one another. Suppose we had put that double bond down there. Well, that's totally fine as well. So let's take a look and make everything happy. So that's good. So we would show that those are resonant structures. And then there's one other place I think we can see the pattern here where that electron can go. Where that one pair of electrons can go. So we've got our double bond to the other side, making everything happy with enough electrons. And we would just draw a double-sided arrow showing those. Now, if you put them all next to each other, that's fine too. All right, let's take a look at our NO2 with a minus charge here. We have 1 nitrogen, love to have 8 valence electrons. 2 oxygen, also love to have 8 valence electrons, so we would love to have 24 electrons available to us. Still 1 nitrogen, group 15, 2 oxygens, group 16, and then we got that negative charge. Remember, that negative charge tells us that there's 1 extra electron. So 2 times 6 is 12, plus 5 is 17, plus 1 is 18. Do our subtraction here, that'll give us 6, divide that by 2, 3 bonds. And if we take a look at NO2, we're going to have, I kind of drew these guys a little dinky, a little small. Not enough room for my bonds there. And so we're going to put our oxygens on either sides, opposite sides, 1 bond, 2 bonds, and let's just make that a double. And let's go around making everything happy. So we're good. There, that makes everything happy. However, I could have just as easily drawn this with a single bond there and a double bond there. Now we go around making everything happy. And the clutch idea here, the key idea, is that the only thing is changing is the location of our electrons. Our elements that are making this up stay the same. So these are resonant structures, but they are also ions, so we have to make sure that we put them in brackets with a charge outside, so -1 and -1. And that's how we do resonance. Simple as that.